India has the largest number of data scientists on LinkedIn. But out of all those, if you ask how many actually are effective, how many actually are able to bring value to the business, then surely you'll have a very different answer. In this episode of The Data Rush, I interviewed Dr. Sarabjot Singh, who's the Chief Data Scientist at Tatras, with 2 decades of experience in the domain ranging from academia, research, and entrepreneurship. Surely there's a lot that you can learn from this conversation, as he decodes the mindset, skill set, and zeal required to be an efficient and impactful data scientist. So, first of all, sir, I would like to ask you before the interview. So, how's your time during the pandemic going on?
I'm actually enjoying it a great deal. I don't have to travel as much as I was,
Yeah.
and I'm getting time at home. And the work is also, my team at Tatras is doing a great job working from home. It was something that I never believed in, that people can work efficiently from home. But I think
Yeah.
people have grown up during this period and taken responsibility, which I think is a boon. So
Yeah.
I think if we look at our own philosophy, Guru Nanak also said, "Ke dukh daru sukh rog bhaya."
Yeah.
So we must see all of these as opportunities to learn and improve.
Yeah, it really helps you to push, and then eventually you realize that there is a lot of possibility and potential. So first of all, I would like to know how did your journey as a data scientist start? So what was that initial idea that brought you into this field?
So actually, it was more luck than anything else, right? So I did not plan to be a data scientist. It's just that, as luck
Okay.
would have it, after I did my undergraduate studies in Hindu College here in Delhi University, I got an opportunity to go and do a master's in what is called engineering computation. So this was in Queen's University in Belfast in Northern Ireland, which is part of the United Kingdom. And when did complete that, the professor who was in charge of that master's gave me an opportunity to do research with him. And that was in the area of optimization. But he was from the civil engineering department. And while it was an interesting project, after a year, I decided this is not something that I want to do all my life. And so I applied to the Northern Ireland Knowledge Engineering Laboratory, a new laboratory that was created in the University of Ulster there. And they were interested in looking at how AI can be applied in the industry. And I was very lucky to get a job there, and as a research assistant. And then from there on, I just kind of it was around the time that the subject of machine learning was coming out of the laboratories for the first time.
Yeah.
And so in the early 1990s, people like Rakesh Agarwal from IBM and a few others like Pitetsky, Shapiro, they were putting together a group of people looking at how can you apply machine learning in industry. And so out there, they started calling it knowledge discovery in databases or data mining at that time.
Yeah.
And I was just very lucky that by 1993, I had an opportunity to go and start working in this area. And I got exposed to it through the University of Ulster.
Yes, sir. In this, I would like to know, as now when the entire data science community is so paced up, where we have a lot of availability of data is huge, and then also the computing power is huge. So at that time when you were conducting the research, so what was the motive behind? Because there was but I can interpret there was not that much of computing power or data to back the researches. So what was the motivating factor at that time?
Even at that time, there were applications that could be addressed, right? And if you look at things like decision trees and algorithms like logistic regression, they have existed a long time before we had GPUs, and they were being applied in industry. Association rule mining, an area that Rakesh Agarwal from IBM's Almaden Labs, was instrumental in getting applications in the real world in retail stores and so on, looking at market basket analysis. Those were all applications that were even valid then. I remember in the early days of working at the Knowledge Engineering Laboratory in Northern Ireland, We were looking at how can we capture knowledge that is ingrained within aircraft manufacturing engineers in Shorts Brothers factory out there of aircrafts that had gone out of production, that had gone out of use in Europe, but were still being used in the third world, in Africa, for example. And when they would get calls for maintenance and issues with those aircrafts, the people who had worked on those aircrafts were long gone, right? So at that time, we called them knowledge-based systems, where we went and learned from the experts and coded that knowledge into computers, right? And created expert systems or knowledge-based systems, as they were called at the time. And so there were still applications of that kind that were relevant. I remember one of the early applications also that we worked on was predicting landslides in Hong Kong, right? So I mean, the applications have not changed. You're right in saying that what has changed is that we have better hardware. So trading can be done faster. We have a lot more data thanks to the Googles of the world that have actually collected a lot of data and Facebook and so on. And so, those problems were being solved with lesser data. There was a lot more human intervention required in learning at that time. So when we talk about feature engineering, we took raw data and we actually used that human understanding of the domain to create features that would make learning easy and possible with the hardware and the algorithms that we had at the time. Right?
So basically, it's like now it is more accessible. At that time, it was there, but now it became more accessible to the general public. At that time, it was more of a luxury. Like only few people had the resources and then the time and everything to be able to research.
And there were very few visionaries, right? So I remember, I mean, it's interesting that I don't know how history will look at this, but there was a small company called Integral Solutions Limited, which was based out of Basingstoke in the United Kingdom, and they were, other than SAS, the big statistical company, they were one of the other companies that actually built a software that had a visual programming interface for machine learning, right? And they called that software Clementine. And we were very lucky that through the university and the work we were doing, we got involved with them also. And so even in those days, there were visionaries like these. When you look back at, this, it seems hilarious, but back in probably 1980, 99 or 98, they sold their company to SPSS for something like 12 million pounds, right? Which in today's numbers sounds like a very
much
number.
undervalued.
Right? And SPSS then was bought by IBM for billions and so on. And of course, it was not only that software that was bought. Of course, SPSS had their own assets. But when you think about it, some people who are early in this game made money, but they didn't make the kind of money that they could have made in today's world, right? And but those visionaries have had an impact, right? Even today in IBM's tool set, the Clementine software, I think they've renamed it as something, but we didn't have as much open source library. So at that time, we had again, amazingly, a software called Weka, which was a Java library for machine learning, and it had been built by a group based out of the University of Waikato in New Zealand. And we used to laugh and say, well, in New Zealand, what else would you do, right? I mean, you have nothing else to do. You're so everywhere. You might as well sit and program, right? So, but those were the kinds of things that started making the software accessible, right? There was also a C++ library called MLC++ that was developed, in the US that was also used substantially. The kinds of libraries we have today in Python or TensorFlow or Keras, all of these things, PyTorch were not available. Scikit-learn was not available at the time. You had to write your own.
Yeah, so as of now, in today's day and age, like thinking about doing ML in Java or C++ is something that no one would think. Like their first priority is always Python and then maybe R. Yeah. Definitely.
I mean, it's become a lot easier, right? I mean, they talk about this being the democratization of machine learning, that, anybody can do it. Though I kind of disagree a little bit with that, right? And, I think you still need to understand the math. You still need to understand the logic behind how these algorithms work, because unlike software development, creating AI machine learning solutions is not, a true or false output, right? You can't get 100% accurate result. And most people in industry don't understand that, right? And they have to recognize that it's not about building a 100% accurate model. It's about doing better than what we are doing today. And that better could be based on the cost, right, of making decisions, or the safety of people who are making decisions, right? And so those are the kinds of things that we need to look at.
Yeah, definitely, definitely. And the main motivation that I had when I was trying to pursue you for this interview was this only, because people like me or the people in my peer group, they like they are sort of following the same template only, starting the Bible courses from N to NG, the same videos. So having this perspective that even C++ or Java could be used for machine learning, and then how in the early ages, the example of aircraft that you were giving. So this is sort of perspective that we don't have. So that was really enriching in that sense. And elaborating, going in deep on the libraries part only. So as we can see that the libraries are sort of giving us a lot of speed. So what's your but then it also makes us lazy in the sense that we don't need to have that deep understanding of the algorithm behind just the parameters that we are passing in the functions, or making the objects out of the libraries and using it directly. So what do you feel regarding that? Is the speed adding up to the efficiency, or making us lazy, and then as we don't then have the better understanding of the algorithm, then it impacts our decision making. So what's your view on that?
Yeah, so I could be considered old-fashioned, right, when I say this, but I think, like I said earlier, if you don't understand how the algorithms work, you are only going to be suboptimal in your use of the library, right? I've seen number of places where companies have hired 10 fresh data scientists who know Python, and in a couple of years they realize that there's no output. Now, the problem there is that, like I said, it's not about software engineering alone, right? There are definitely software engineering aspects of that. And But in general, you need to create what is, a machine learning pipeline that goes from the business solution to business value,
Yeah.
right? And if we look at what is being done today, and to some extent, Kaggle is also helping create this environment where people think that it's all about just hyperparameter tuning. Right? And the truth is that when we talk about auto ML, for example, I think people's jobs are at risk who only look at that level of machine learning, where they're saying, okay, I take an algorithm, my favorite algorithm, I'll do hyperparameter tuning, and I'll have a solution, right? But that's what AutoML can do very well. There's no reason for a human to be involved there. Where the human is really required is at interpreting a business problem, figuring out what is the data, creating the access and pipelines to the data that bring the data in a form that can then be consumed by the algorithm. But when the algorithm does not work well, you really need to start looking at, so what are the alternative solutions? How can I tweak things, right? Because the human real world is very different from data sets we typically try and use when we are trying to learn how to use an algorithm.
Definitely.
So there are always nuances in the data that actually invalidate some aspects of the algorithm, or don't give the kinds of results that are reported in research papers. So if you really want to make an impact, you've got to understand the algorithms, right? And a lot of people, and in fact, I was giving a talk at a Microsoft event recently, organized by NASCOM as well, where they were talking about how the cognitive services from Microsoft are available, and so everybody can use some kind of image analysis within their tools and so on. But that's true. But at the same time, if you're a startup that's trying to create a disruptive solution for something, depending on a third party like Microsoft to innovate for you is never going to put you in a good place, right? So if you are a startup that wants to create a solution where you can take a photograph of a car and you actually that is damaged from an accident, and you get an insurance prediction of what is the damage cost. If you're going to depend on standard libraries or open source software, where is the barrier to entry? Right, anybody can do that. There's so many people who are saying, oh, we can actually create video analysis tools that will tell you how many cars are passing this crossroads today. And all they are using is using YOLO as the algorithm, right? And they are saying this is our solution. But when I ask them, what is your innovation in this, they don't have an answer because they don't even know how YOLO works. They don't even understand the neural architecture behind it, right? And that is a problem. So, every industry goes through this. There's a boom and a bust. I think we will see a bust in AI. We've had AI victors before, but because we have so many people, we have more data scientists in India than actually in the rest of the world, right? On LinkedIn. Because everybody who knows a little bit of Python says they're a data scientist. And I think that is a problem, and we need to address it. And if we don't address it, then we are going to hurt ourselves.
There's one more important fact in that, and that's like there are a lot of people who are pursuing the field of data science, but then eventually when they want to stand out, or like their resumes are like almost the same. So, and then a very important point that you highlighted was regarding the innovation. So then if they can basically ace a specific given path, but in order to have the ability to build a new path is something that the startups specifically in India, and then also at this time where innovation is required so much, where the economy is like already going down, and at this point we would require leaders. So to have that mindset is something that we lose when we are following the same path.
Yeah. And I think, we have a lot of wonderful things about our country. But one thing that we have never taken seriously is the education system. And while we have the IITs and so on, the truth of the matter is that there are a lot of very intelligent kids that are not IITians also, right? Who have not got access or opportunities because of the fact that maybe they were just put off by a teacher in school, right? And therefore did not pursue it to the level that they could. To us, our education system teaches us not to question. It tells us, vadiya nahi gal suno, right? It tells us from birth we are told not to question. And one of the key aspects of innovation is to question. Right? So, we need people that we can ask questions to who are brave enough to say, yeah, I don't know the answer. Because no human can know all the answers. So for us to also have that expectation of our teachers that, they should know all the answers, that's also wrong. Right? So we need to change our mindset. We need to kind of get into a place where it's fine to ask questions. There's nothing such as a stupid question. If we don't get into that, we will never be able to innovate.
Yeah, definitely. Also, when you were talking, I was like trying to relate it through the deep networks when we talk about that. At every back propagation, it just matches the original value, and even if the machine is checking that am I close to the correct answer or not, we as humans who have built such machines can also learn from that always questioning ourselves at every iteration in our lives.
Questioning ourselves is very, very important, and allowing ourselves to be questioned is another really important thing, right? So if you look at very innovative leaders, they've always talked about the fact that the worst thing you can do is you can surround yourself by people who keep telling you you're wonderful and never question you, right? And that is the nepotism that we will see today in politicians. We will see it in kings of the past, right? Who ended up losing their kingdom. And we are doing the same thing. We are losing our kingdom by saying that, don't ask me questions. Right? So our education system needs to fundamentally change for us to actually become capable innovators.
Yeah, so I was reading a quote which said that that good times, like bad times, lead to good. Bad times make good leaders, and good times lead to weak leaders eventually, because then you stop pushing yourself and then you lose everything. Like we have the standard example of like the many of the Mughal rulers, like when Shah Jahan was building Taj Mahal, so he invested everything into building Taj Mahal, all the resources, but eventually he got conquered because eventually he was not investing in his army, and eventually you like when you stop like making your tools or knife sharp, then eventually you are not able to make that impact because you are not working. Definitely, yeah. So now another very important query, or must say the question that I have is like, as we can see that each and every day there's a new innovation in terms of a new algorithm that's coming. Like even at like some time back, NLP was and still is was at very much boom, and then like people every day there's new algorithm that we are talking about, like BERT or all the new algorithms, and everyone just like fancies that yeah मेरे को इस algorithm के बारे में पता होना जरूरी है. But like as per you, like being at your level, like having 2 decades of experience, so how are you coping up with that, or how shall anybody cope up with that? Like because when you're learning new things, you can do two things. Either you can learn new thing every day, or you can try to master one of the new thing that you learn. So like how can one draw balance between mastering and then catching up with the new stuff?
See, I think learning on a continual basis is going to be the way of the world in every subject. It's not just data science, right? And so we always need to recognize that there's no such thing as a job for life. There is no such thing as "main padh liya, now I don't need to study anymore." Right? So you've got to continually upgrade your skills. The truth is that there is a lot of publications happening today in the data science world. A lot of it is also noise, right? And you know, so being able to go through these papers and understand. So when we talk about, everybody says, "Okay, you know, I want to now work with BERT." It's not about working with BERT. It's actually working with the library for transformers, right? And that is the problem. So you need to understand the progression. You know, you need to be in a situation where you can say, okay, I understand multi-layered perceptron. I understand how a CNN differs from a multi-layered perceptron, right? Really, it is still a very large neural network, right? All that you're doing is you're doing weight sharing, right? Parameter sharing out there. RNNs in a similar way are exactly the same, only that we are specifically looking at sequence. Now, in the sequence data itself, you know, RNNs and LSTMs, you know, the difference between them and the attention-based models, you know, understanding those concepts, right? So positional encoding, right, within BERT. Understanding that is important, because then you have a grip on what is the foundation. You build a strong foundation. On top of that, you can put as many buildings as you want. Right? So the problem is that we are sitting on a weak foundation. Right? Everybody is kind of, because, you know, unfortunately, we have a lot of people who are just trying to make money out of this, right? By putting up training courses that are not very useful. So and kids don't have the safety net that they can actually get protected with when they are falling off. So if you look at groups, for example, the number of people who start a course is much larger than the number of people who actually finish a course. Of the people who finish the course also, a lot of them actually have a very limited understanding. So it's not like they are very useful as data scientists today, right? So the important thing here is to build that foundation. Take your time to understand what's happening there, right? And the biggest problem today is that kids don't have mentors that they can ask. Right? And say, okay, I don't understand this. So what is exactly happening here? And let it be 200 times that you ask the same question, but build your foundation. Be selfish in that respect. Today, unfortunately, I find that people are all looking at how can I multiply my earning. Right? And so there are so many people who are just looking at large increments. You know, we've got to be realistic about what our expectations are also, right? I mean, as an industry, if we start giving 50% increments every year to people, we'll become more expensive than the US in a few years, right? And can we afford it? We can't, right? So it's important that kids, especially at a younger age, they focus on building a strong foundation. And it is our responsibility as people who are now, looking after the education that's being provided, that we give a good education and a foundation. Right, so that we can build this group of people who can compete with the best in the world. It is, after all, only our Indians who go there and blossom in the US, right? So many cases where these people go, they blossom because of the opportunity. They're not more intelligent than anybody else. Right? Every child comes with an equal amount of intelligence. After that, it depends on what exposure they get. 80% of the kids don't get a good exposure because they live in terrible states in the country. So they don't get a good education. They get exposed to people who are not interested in educating them. So they lose their will to learn. And the rest of the 20%, maybe 15% of them are in urban areas getting, poor education there also, right? Because most of the people who are teaching are not really interested in teaching. They only see this as a job that they can get back to the children after.
So definitely it's like if you are not building your foundation strong, so it's like you are either following your master, right? So you are just following the steps. You are not building that mindset. But like eventually, even it's if we relate it to data science or any other domain, so when you actually start thinking as a data scientist is when things shall change, because eventually, in that case it's like if I just give the example of a normal problem solving scenario, it's like it's not like always you will have all the problems sorted, you will have solutions to all the problems, but then eventually if you have that mindset of solving a problem, so eventually you'll follow your process and trust more on your process. So I think that is something that we miss out when we don't have the foundation strong, because then we are not thinking in that perspective.
Right. And a very important part of learning is to find the patterns themselves. Right? As data scientists, that is what we are doing. Right? We are finding patterns in data. Same way, when we are going through education, we should be able to see the patterns. We should be able to ask questions. Right? We hear about topic models. We hear about embeddings now from the neural network community. We hear about latent variables from the statistics community. They're all the same. Hidden variables, right? All of this terminology that's coming because people have tried to attack the problem from different areas, right? From cognitive science, from neural computing, from information retrieval. So matrix factorization is actually doing something very similar to topic modeling, right? All of these things are the same. So if we actually look at it, there is a core of machine learning that we can actually get a fairly good idea of in a couple of hours, right? But the problem is that nobody teaches it that way. Everybody teaches it as this is a decision tree algorithm. This is what logistic regression does. This is what linear regression does. And students are thinking these are all distinct, things. But in the end of the day, what we are doing is we are fitting a function to our data. And what is that function? It's actually a probability distribution. Right? And we talk about, Bayesian probability is useless. Neural networks is the thing to do. But what is a neural network doing? Most of the time, it's actually learning a probabilistic function.
So there's also one urge of everybody that they want to act or like talk in a smart manner that they know that. So in this thing I would like to add one part, and that's that the compounding effect that we talk about. Like I was going through a blog of somebody, so he was saying that when we talk about deep learning or machine learning, so it's like if you get your basics strong, so eventually it's like the next model is some sort of a improvement to the initial basic model. So in that sense, from one model to the other, there was a difference of 0.1%, right? But eventually, if after third or fourth iteration through the new model, we can see that from the starting, it's a increment of like 1%. But then that 1% was eventually zero point 0.1 plus zero point 0.1 that added to that. So I feel that the compounding effect is something that that's like applied everywhere. So like if your basics are strong, then every time a new model that you are looking into, all your previous research and understanding then compounds plus the new thing that you're learning.
Yeah, yeah. No, absolutely. And I think we are not investing in the foundation being strong enough. And that's the problem. I mean, I've seen this throughout, right? I mean, we first saw decision trees as being a great algorithm. We then saw SVM became the flavor of the month, right? Support vector machines. And if you had a research paper that did not compare your new algorithm with an SVM, then you were not going to get accepted as a paper. You then looked at, ensemble models and random forest and gradient boosted decision trees. And then, of course, neural networks at one stage was considered to be useless because they overfitted and too long to train. And now they are the flavor of the month, right? But the truth of the matter is that these are all tools that we must have in our toolbox as data science. Never can we say that one method is going to always work better. There are applications where simpler models like logistic regression still beat, neural networks, right? And at that point, why should we use a neural network where they are difficult to explain? Yes, of course, work is being done in explainability, but in the end of the day, there was one thing that we learned early on in machine learning, which is the Occam's razor, which is keep it simple, right? So always build the simplest model that gives you a good solution, right? And most people don't even know how to compare two algorithms' accuracy. One algorithm has an accuracy of 94% and the other 94.1. It does not mean that the one that got 94.1 is a better algorithm or a better model, right? We are learning from a sample of data. So we must learn about hypothesis testing to be able to say, is this model always going to give me better results? Or I get another sample, it could switch very easily, right? The first model could give me a higher accuracy than the other.
Definitely, that's very important. And then one thing that I also think in this thing is that at what cost is the accuracy coming in? Like from 0.9 to 0.92 if you're giving that accuracy. So what's the cost that it is coming in? And the other point that you mentioned, like the simplicity is like very undervalued. But I think because eventually, as you said, that eventually you are providing value to the end user, to the person in the domain who is going to use it in whatever functionality we may consider. So in that case, being able to explain the complexity in a simple manner to the end user or the stakeholder is very important. But when you cannot explain the entire back propagation, forward propagation,
and that's not what they want to understand anyway. Right? So the understanding, when we talk about explainable AI, we are actually trying to say this is the reason why I made this decision, right? So this is the super pixel that caused me to classify this as a dog rather than a cat, right? Or that this is an oil spill versus not an oil spill, right? Or this is an eruption on Mars and not an eruption on Mars, right? I remember back in 1993, I think, in AAAI, I was amazed by this application that Porrick Smith and Usama Fayyad presented, right? These are great names in this space that we can only aspire to be like. But they were working in jet propulsion laboratories at the time, at least Porrick Smith was. And they, at that time, in 1993, were looking at volcanic eruptions on Mars, right? So when we talk about, what were the kind of applications, we have lost sight of those kinds of applications that people are still working on, right? So like I said, the problems remain the same. It's just these fantastic, passion projects, right, that you can get excited about. Every data scientist needs that passion. And that's another thing that I think a lot of our kids miss out on, right? We don't get an opportunity to create a passion. I have friends in the United Kingdom that have built kit cars, right? For built by hand a car to race, right? We don't have too many people who do that kind of stuff, or at least maybe I grew up in an area where we didn't have this. But the percentage of people that have something that is a passion for them throughout their lives is, I think, a very small percentage in India compared to the rest of the world, right? And it's that what we have to nurture in kids, that they can actually get excited.
Yeah, so it's like in our case, we always evaluate that what's the return over this investment, because eventually when you're going the route of passion, you would do something that might not be as profitable, but because of that passion inside, you would pursue that.
Yeah.
Yeah,
And the truth of the matter is, if you're not passionate about what you're doing, you will never be good at it, right? So even when people are now jumping onto the data science bandwagon for the wrong reasons, they're going to burn out, right? A lot of people join data science and then leave it because they, have not been able to really perform out there. And the
yeah,
reason for that is that they've joined because they hear it's a better prospect, right? Better salaries, and that's not the reason to become a data.
yeah.
Really, it is a laborious task. It is a horrible task to be a data scientist, right? Because I
Talking
have so
from the
many.
heart.
No, no, true. I mean, it is the most exciting thing. At the same time, it is actually a drudgery also, right? I mean, most interns that come to me, they are upset until I ask them to run some kind of neural network model on TensorFlow, right? Till then, they don't feel that they are worthwhile, right? I'm the one who ends up manipulating data even in Excel, even though I hate Excel, but sometimes you have to do that
Yeah,
kind of stuff, right?
yeah,
My whole thing is that nothing is too small for us. As human beings, we need to realize that, right? That
yeah,
we often try
definitely.
and kind of look down upon stuff and say, "Main nahi kar sakta. This is below my
Yeah,
dignity to do."
yeah,
The truth
yeah,
of the matter, as a data scientist, you have to get down to low level data and manipulate the data. And if you
yeah,
think you're going to get away with that, and partially the deep learning community is at fault here, right? Because they say you don't have to do anything. All feature engineering is done by the
yeah,
neural network and this, that, and the other. The truth of the
yeah,
matter is that you still have to work really hard on your
yeah,
data, right?
yeah,
How do you collect your data? How do you ensure that there are no biases in the process of collecting data? These are all
yeah,
problems you need to solve as a data scientist. And it's not about just running an algorithm, because that's what AutoML is going to do for you. So if that's the kind of data scientist you're going to be, then you'll be out of a job.
yeah, definitely. So, like when you were talking about like burning out, or like there's like no limit to the human potential. So I'll share my experience. So it was like when I was going through trying to implement the TensorFlow library. So as you might also recognize that when they transition from the previous to the next version, so there was at point they didn't give that much of support, so there was always some sort of library issue that used to come. So I had built the entire model using the syntax that was provided, but then it was showing key TensorFlow key ye error आई and all that. So I went to Stack Overflow, tried to search everything, and I felt like sort of pissed off. But then I thought कि मैं इस इतनी सी बात को लेके like I'm like so concerned, and मैं I'm losing the hope. But there are like people from ISRO who decided that the Chandrayaan or the Mars mission that they were conducting, that the satellite would first revolve around the Earth, get that velocity, then reach there, and so they planned to that sort, and they were able to achieve. And मैं एक ये छोटी सी प्रॉब्लम नहीं सॉल्व कर पा रहा हूँ, so like there's like a lot of mind shift that comes
Yeah.
into that.
Yeah. Yeah. But I mean, at the same time, I think there's no excuse for not giving support, right? So if you're putting a library out, you should give support.
Yeah,
And, I think part of the reason why there's, some people look at this as almost like it's black magic, the whole machine learning AI piece, is the fact that we are not good at explaining, right? We are bad at teaching. So the papers that we write are not clear enough for somebody to read and understand, right? And so we all need to reflect upon that also. Too many people are too busy trying to uh, put their name out there and get lots of followers in LinkedIn, or get lots of people to kind of like their blogs.
yeah,
Why write blogs when you have nothing new to contribute?
Yeah.
right? Why write papers if you are going to write them in ways that are actually impossible for people to do, right? So, statisticians are a great example of how, you should not do things, right? Statistics books are most difficult to parse. Why? The concepts are not difficult. So if we can actually write them, and I think that's where there is innovation and possibilities, right? For people to be able to make it more accessible. The way to make it more accessible is not to write a library and say you don't have to do any statistics now.
Yeah.
Right? It is to actually write something so that it's easily approachable and you can understand it. And until we can actually get every kid who's really truly interested in data science to be able to understand, then till then we are failing.